All right, let's learn about momentum and calculate momentum given known variables. So what is momentum? Momentum is a quantity describing the mass and velocity of an object. Momentum can be used to analyze and predict the results of collisions and explosions. That's why physicists love this thing. So momentum, we use it in our vocabulary. You might have heard something like this. Going into the second half of the game, the UCSB Gauchos have momentum. They're going to be hard to stop for the opposing team. I use these words carefully, and we might have heard this type of thing in our daily lives. So momentum is sort of part of our daily lexicon. Momentum is a quantity, meaning it's an amount. So momentum, remember, it's a combination of an object's mass and velocity. It's a vector quantity, and that just means that the direction matters. You can see this football over here has a momentum of -6. That negative is telling me that that object is moving to the left. Now, the shorthand way to write momentum, in physics, we always have our variables, our symbols, and then we have units of measurement. And the symbol for momentum is P. I'm not quite sure why they use P. I think M was already taken for mass and meters and other things. The units for momentum are kilograms meters per second. It's just kg times n/s, but we say it kilograms meters per second, that whole mouthful. So that football in the last slide, it had a momentum of -6 kilograms meters per second. So when we calculate momentum, we want to multiply the mass times the velocity. And this is the shorthand way to write it and remember it. P equals M times V. So let's take an example. Here's a baseball. It's 2 kilograms, and it has a +5 meters per second of velocity. I'm going to write my equation, and then I'm going to plug in the values that I know. I know the mass is 2, and I know the velocity is 5, and so I'm going to plug it in. I'm plugging those into the formula. That's a process that we call substitution. We're going to solve by substitution. Good. Remember this. This is our strategy here. And then when you have 2 times 5, you get 10, and that's your answer. Easy peasy lemon squeezy. So the momentum of the baseball is +10 kilograms meters per second. Here's a couple examples I want you to solve. So sometimes we'll get word problems with momentum. For example, a 10-kilogram dog runs to the left with a velocity of 4 meters per second. Calculate the dog's momentum. So our strategy, let's write down our equation. P equals M times V. Let's substitute in the values that we know. We know M, the mass, is 10 kilograms. The velocity is -4 because it's moving to the left, -4 meters per second. 10 times -4 is -40. And in physics, we never forget our units. The momentum is -40 kilograms meters per second. I just added those units in there, and I have a perfect correct answer. Frankie's happy, I'm happy. Okay, here's one for y'all to solve. Sometimes we have to use algebra to solve for an unknown variable. Here's an example. A 2-kilogram cart moves to the left with 30 kilograms meters per second of momentum. How fast is it moving? So in this one, we want to figure out how fast. So we actually want to solve for velocity. But let's use the same strategy. Let's write down the equation. P equals M times V. Let's plug in or substitute what we know. We know it's moving to the left. So it's got -30 kilograms meters per second. I'm going to plug that in right there. We know that the cart's mass is 2 kilograms, and I'm going to leave my unknown variable velocity as just V. Next step. V was being multiplied by 2, and I'm going to use the principle of opposite operations, my algebra rule, where if I have a times 2, now I got to divide by 2. The opposite of multiply is divide. And what that does is now those 2's cancel. And then the other rule of algebra is whatever you do to one side, you've got to do to the other. You all know this. So I have to divide that -30 by 2, and I end up getting -30 divided by 2 equals 15. So I'm keeping my work really nice and organized as I'm going down, and I find that the velocity is -15. But in physics, you never forget your units. So it's the cart is moving at -15 meters per second. And that's how you do these. Easy peasy lemon squeezy. Here's another one for y'all to solve. You got this one. Lastly, here's some important ideas. Momentum depends on speed. So, increasing speed means you're increasing your momentum. This little astronaut, if he hits his jets and he speeds up, he's going to increase his momentum. Decreasing speed means decreasing momentum. Constant speed means constant momentum, and a zero speed means zero momentum. Momentum depends on speed. Here's another important idea. The momentum for an object will change in a collision. This guy's running with his yoga ball in this direction and he collides. His velocity changed, so he's going to experience a change in momentum, and we can write it with that little delta P, just like that. If an object experiences a change in velocity, the object will experience a change in momentum. Lastly, an object with more momentum will overtake an object with less momentum. We have these two football players, and this guy, the blue football player, has 21 kilograms meters per second, whereas the red football player only has 20 kilograms meters per second. If they collide and we're going to neglect outside forces, they're going to end up moving to the left because we have more momentum on this side. And that's it. That's momentum, and that's how to calculate it. You got it.